When plastics are heated enough, they become liquid that flow and deform. While they can be mixed or molded in that state, they are still viscous and elastic. If plastic melts were quite viscous for manufacturing processes, it would cost much energy or take long time. But if the melt strength is not high enough, plastics cannot sustain shape during some processes, such as blow molding. So, we want to modify the properties of plastic melts, sometimes to lower melt viscosity or sometimes to raise melt strength. Now, how can we do these? It's simple. If we blended plastics with lower molecular weight polymers, the molecular weights of plastics would decrease, and then the melts would flow faster than before. Increasing the melt strength can be done by the application of branched polymers, because they make polymer chains have more chances to entangle with each other. Let's see some experimental data. Here we have a flow-improving styrene acrylonitrile copolymer. Its molecular weight is about half of the other polymers. Its volumetric flow rate is about 3 to 5 times larger than the others. When the flow improver was added by 5 part into an ABS product, the volumetric flow rate increased by 20%. The improvement in melt strength by adding a branched polymer can be characterized by extensional rheology. This experiment shows the increment of elongation viscosities with the amount of the melt strength enhancer. If you have any question about flow modifiers, please contact us or visit fineblend.com.cn. Thank you.